Throughout history, for more than 2 millennia, mathematics has stood as the absolute, ultimate test of pure human reasoning. We've built machines to handle massive calculations, crunching millions of numbers in a fraction of a second. But the discovery of new mathematical truths, the intuitive leaps of logic, remained strictly human territory. The rules of this intellectual province were laid down by pioneers like Euclid. They established a system where logic and human insight work together to map the unseen architecture of the universe. In the 20th century, that tradition was championed by the prolific Hungarian mathematician Paul Erdős. Over his lifetime, Erdős collected more than 1,000 notoriously difficult, unsolved puzzles. These problems were considered completely secure from the reach of machines. Solving them requires an aesthetic sense of logic that the math community believed was impossible for a computer to replicate. Last month, in southwest England, a teenager named Liam Price sat at his computer. He lacks any formal mathematical training, yet Price managed to solve Erdős' problem number 1196. It's a complex puzzle concerning primitive sets of whole numbers, and it has baffled professional mathematicians since it was first posed in 1966. To confirm the math was sound, Price worked with Kevin Barreto, an undergraduate at Cambridge University. The proof holds up under rigorous academic scrutiny. Price didn't achieve this through raw talent alone. He used ChatGPT, a general-purpose language model, a system with no specialized mathematical training, cracked a cold case that eluded human specialists for nearly 60 years. How did a simple chatbot built just to predict the next word in a sentence discover a completely new form of mathematical reasoning? For decades, researchers who tried to solve problem 1196 relied on probability theory. They would begin their attempts by rephrasing Erdős's original question to fit that specific framework. Professional mathematicians often operate with a shared sense of convention. They gravitate toward methods that feel elegant to a human mind, and that collective intuition can sometimes turn into a collective bias. ChatGPT ignored those conventions. It solved the puzzle in its original language, exposing a mathematical path that humans had overlooked for half a century. The result caught the attention of UCLA mathematician Terence Tao. He noted that the machine's approach established an invisible link between numbers and probability, a connection experts hadn't seen. A researcher at Stanford compared the breakthrough to a computer playing chess. The machine found a winning opening move that humans were blind to, simply because we were trapped by our own traditions. The speed of this development has caught researchers off guard. Just a year ago, many experts assumed language models were restricted to their training data, capable only of repeating existing information. While earlier models did rehash known literature, this solution marks a shift. The machine is showing the first signs of original mathematical thought. This diagram illustrates how the AI operates. It identifies structural patterns between different, segregated subfields of mathematics. It is building bridges between these isolated concepts entirely on its own, without any human prompting. Unlike human researchers, these models possess total recall of published literature. They don't lose focus, and they don't get demotivated by the difficulty of the task. These connections suggest the computer's role is changing. Instead of simply verifying human work, it is starting to uncover mathematical truths on its own. But this expansion comes with immediate consequences. Mathematical journals are facing an influx of AI-generated submissions, a phenomenon researchers are calling AI slop. The current generation of models has a specific limitation. They can construct logical proofs that are 3 to 4 pages long. Beyond that, they begin to make subtle, highly technical errors. This places a burden on human referees. Because the machine's output looks convincing, reviewers spend hours trying to figure out if a complex paper is a genuine breakthrough or a sophisticated hallucination. We've reached a point where generating new ideas is no longer the main difficulty. The primary bottleneck to progress is now our ability to verify them. That verification crisis will likely intensify. Major technology labs are already testing internal models capable of generating flawless 10-page mathematical proofs. This reality is forcing mathematicians to ask a difficult question. If a machine can match our logical reasoning, what is it that makes human creativity unique? The answer to that question will be tested at the highest levels of the discipline. The Fields Medal remains the ultimate symbol of human intellectual achievement in mathematics. Yet researchers at Google DeepMind are predicting a shift in how that award is won. They expect that by the year 2030, a human and an AI will jointly receive it. The 2,300-year tradition of solitary human mathematics is changing. In the coming years, the most significant breakthroughs will likely be the result of humans and machines navigating these problems together.